Electricity has been moving in the world since clouds first formed on Earth. Lightning is a form of electricity. It's electrons moving from one cloud to another, or jumping from a cloud to the ground. As a species, we watched this, we observed it, and then we learned how to harness it through circuits. Understanding electricity and circuits, which are such a big part of our lives, starts by understanding something very small, the atom. Everything in the universe is made of atoms. Every star, every tree, every animal, the human body is made of atoms. Air and water are too. Atoms are the building blocks of the universe. Atoms are also so small that millions of them would fit on the head of a pin. Atoms are made up of even smaller particles. The center of an atom is called the nucleus. It's made of particles called protons and neutrons. The protons and neutrons are very small, but electrons are much, much smaller. Electrons move around the nucleus at a great distance from the nucleus. If the nucleus were the size of a tennis ball, the atom would be the size of the Empire State Building. Atoms are mostly empty space. Electrons are found in the invisible clouds on energy levels. They're held in these levels by an electrical force. The protons and electrons of an atom are attracted to each other. They both carry an electrical charge. Protons have a positive charge, and electrons have a negative charge. The strength of the positive charge of the protons is equal to the negative charge of the electron. Opposite charges attract, holding the atom together. Electrons require energy to be able to escape their attraction to the nucleus. Electrons closer to the nucleus require more energy to be removed from the atom than those further away from the nucleus. If these outer electrons get just a little extra energy, they can escape to other atoms. When the movement of electrons is in mostly one direction through an object, the movement is called electricity. Conductors and insulators pass along these electrons differently. Conductors are the types of materials that have electrons held loosely in their outer energy levels. Because they're held loosely, they can be pushed along easily. That means electrons flow very easily, passing along that negative charge. These are materials like metals, silver, copper, and electrolytes such as salts. On the opposite end is insulators. Insulators hold on to their electrons very tightly in those inner energy levels. That means they're very hard to push along. It takes a lot of energy, so electrons do not flow very easily. This prevents electrons from flowing. We see this a lot in plastic, rubber, air, and glass. This is why a lot of electrical equipment is either insulated or coated with rubber or plastic. When electrons are allowed to flow through these conductive wires, this LED lights up, transforming from chemical energy in the battery to electrical energy to radiant light energy. If you try to close the circuit with some tap water, the LED barely lights up. This is because water on its own is not a strong conductor. Electrons flow, but not as freely as when salt is added to the water. The electrolytes released in the salt water prove to be a better conductor than the water alone. We can apply this observation to make our own conductive Play-Doh using some common household items. All you need is some flour, lime or lemon juice, vegetable oil, food coloring, salt, and some tools to mix them up. I'm going to roll this dough into a basic circuit. Electricity travels in closed loops called circuits. It must have a complete path before the electrons can move. If a circuit is open, the electrons cannot flow. Electricity makes our lives easier, but it can seem like a mysterious force. Measuring electricity can be confusing because we can't always see it. We're familiar with terms such as watt, volt, and amp, but we often don't have a clear understanding of these terms. We buy 60-watt light bulbs, a tool that needs 120 volts, and vacuum cleaners that use 8.8 amps, and we don't ever stop to think about what these units mean. Our first measurement is called voltage. The pressure that pushes electrons in a circuit is called voltage. Voltage is a measurement of the pressure applied to electrons to make them move. It's a measure of the strength of the current in a circuit, and it's measured in volts. This tool is called a multimeter. It's able to measure the voltage of our circuit. As the two leads get closer and closer together, the voltage drops. Measuring the voltage directly from the two ends of my battery helps to explain why this is called a 9-volt battery. It has an electrical potential difference of 9 volts. Voltage is the force that pushes the electrical charge through the circuit. This force works like the pressure in a hose. If you increase the water pressure, you increase the force pushing the water through the hose. Increasing the voltage creates a greater force because you're creating a greater difference in potential charge that pushes along those electrons. The potential difference between these 2 points changes because of resistance. Resistance is a property that slows the flow of electrons, or the current. Resistance acts like friction, slowing down the electrons. Resistance is measured in units called ohms. There are devices called resistors with set resistances that can be placed in circuits to reduce or control the current flow. Every load in a circuit has resistance. This includes lights, motors, etc. Think of the circuit as a highway. The cars act like the electrons passing their charge through the circuit. Traffic acts like the resistance in that circuit. A toll booth or a car accident can increase traffic and slow down the flow of cars. Similarly, all electrical loads have resistance and slow the current or flow of electrons. The resistance in the Play-Doh slows down the electrons. Cutting the Play-Doh stops the electrons. Bridging that gap with an LED shows us the electric current. The LED only works when aimed in one direction, so the current must be flowing in one direction. The electric current is the flow of electrons. It can be compared to the flow of water in a river. A water current is how much water passes you in a given time, whereas an electrical current is measured in amperes or amps. 1 ampere is 6.25 times 10 to the 18 electrons per second passing through a circuit. Voltage, resistance, and current can be visualized by watching Winnie the Pooh. Pooh Bear trying to move through the hole is like the current flowing through a circuit. Rabbit applies a force to help Pooh move through the circuit like voltage. Unfortunately, the tight hole acts like resistance, slowing Winnie the Pooh down as he tries to become unstuck.